So folks, in this video we want to practice using our inverse trig functions. And the most important thing to remember is to write out this sentence, where on, and then you list the restricted interval. So when I'm asked this question right here, we're trying to evaluate the arc sine of the square root of 3 over 2, and the answer should come out in degrees. Well, let's first just remind ourselves what the arc sine does. So as a reminder, when we take the sine of an angle, it returns a ratio. And so when we take the arc sine of a ratio, it should return an angle. Okay? That's the first thing. The next thing is you need to remember the restricted domain. In our case, the restricted domain is not minus pi over 2, or I mean it is pi over 2 to pi over 2, but we're going to be doing this in degrees, so we're going to say on the interval from minus 180 degrees to 180 degrees. And what we should do is we should draw for ourselves a unit circle, and on that unit circle we should label the restricted domain that we're talking about. So we're talking about this interval on the unit circle, either going this way, opening upwards. Folks, I have a mistake here. This should be minus, not 180 degrees, but minus 90 degrees. And so where on the unit circle, but where on this interval, do we have the desired trig ratio? So this will be all the way up to positive 90 degrees and all the way back to minus 90 degrees. So again, that's a little bit strange, but I'm thinking about opening up from 0 here, so we're going up from 0 degrees to negative 90 degrees, or all the way up to positive 90 degrees. Okay, so here's the sentence we have to be careful to write. We don't want to just ask, where is the sine of theta equal to the square root of 3 over 2? Because the answer to that question is there's infinitely many answers. And we have to make sure that we give the answer that's on this restricted domain. So the sentence that I ask you to write is, where on minus 90 degrees to 90 degrees does the sine of theta equal the square root of 3 over 2? And in this case, that happens up here at this angle, and so that's at theta equals 60 degrees. Notice we're doing this in degrees. By the way, for inverse trig functions, I'm supposed to always specify whether we're in degrees or radians. If I don't specify, then I guess you should assume that I'm in radians, but it really would be polite if I specified. Okay. So I want to point out that the answer to this question then is that the arc sine of the square root of 3 over 2 equals 60 degrees. And we need to check two things if we're going to verify this is the answer. Not only is it true that the sine of 60 degrees equals the square root of 3 over 2, but it's also true that 60 degrees lies within this restricted interval. Okay. So let's try this question over here for letter B. Let's try this question about the arc cosine. Again, we take the arc cosine of a ratio and we expect it to return an angle. Okay? As opposed to when we take the cosine of an angle, we expect it to return a ratio. Okay? What is different here, though, when we're dealing with the arc cosine, is that we have a different one-to-one interval. And for our restricted one-to-one interval for cosine, we're going to use either 0 to pi radians or 0 degrees to 180 degrees. So that's a different interval. So let's sketch that right up here. So we're going to only consider this interval on the unit circle, meaning even if the cosine value gives me what I want down here, we throw it out because it's not on that restricted interval. Going this way, opening it up to pi radians. Okay, so again, we need to make sure we ask this question. So I'm going to ask, where on the interval 0 to pi does the cosine of theta equal minus the square root of 2 over 2? So this is important to keep in mind because there's actually two places on the unit circle where the cosine value equals minus the square root of 2 over 2. And in fact, my cosine curve, which remember looks like this, has a value of minus the square root of 2 over 2 infinitely many times along this horizontal line here. But we only want to give one answer, and we need to make sure that our answer is in this restricted interval. So the answer to this question is right here, which that's the angle 3 pi over 4. So now I'm ready to answer the question. The answer to the question, what is the arc cosine of minus the square root of 2 over 2, the answer to that question is 3 pi over 4 radians. It's the answer for two reasons. First, if I take the cosine of 3 pi over 4, I do indeed get minus the square root of 2 over 2, but also 3 pi over 4 lies in the interval 0 to pi. So I would not, for example, give the answer 5 pi over 4, even though the cosine of 5 pi over 4 is also minus square root of 2 over 2, because it's not in that restricted interval. Since I drew the graph here, I might as well show you. Here's that restricted interval on the graph of the cosine function. So this is between 0 and pi, and there's where pi is on the graph of the cosine. So that's the restricted interval on the graph of the cosine. So the only answer I give is this answer right here, and not any of the other infinitely many answers that we could potentially give. Okay, let's try this again. Down here, we've got the arctangent of minus 1 over the square root of 3. And so, again, we have a restricted interval. For arctangent, our restricted interval, or for tangent, we restrict to the interval minus pi over 2 to pi over 2. And the way we think about that is if we were to go look at the graph of our tangent function, which has these infinitely many vertical asymptotes, and it's pi periodic, it repeats itself every pi. This graph is not one-to-one. So we can't find the inverse of tangent of x. But I can restrict myself to a single region of the tangent curve, and this red region, this that I just colored a different color here, this region right here does indeed pass the horizontal line test, just the colored part. And so there's my restricted interval that I give for my arctangent function. So the question we ask is, where on minus pi over 2 to pi over 2 does the tangent of theta equal minus 1 over the square root of 3? On the unit circle, the part of the unit circle that we're looking at is this interval right here. This is always a little bit strange. I open up this way, so I go this way up to pi over 2, or I go down this way to minus pi over 2. The only answers I'm allowed to give have to be in this region when we go to answer the question. So the answer to this is theta equals minus pi over 6. And you can check that by taking the tangent of minus pi over 6. If you were to take the tangent of minus pi over 6, remember that's the y-coordinate upon the x-coordinate. So it would be minus a half divided by the square root of 3 over 2, which reduces down to minus 1 over the square root of 3. So yep, the tangent of minus pi over 6 does equal negative 1 over the square root of 3. But more importantly, or equally importantly, I should say, it also lies in this interval. Minus pi over 6 is somewhere in this interval here. There it is right there, minus pi over 6. So I can't give answers that are way out here in other segments of my tangent graph, because when I do the arctangent operation, I have this restricted domain that I'm dealing with. So let's now give the answer to the question. The arctan of minus 1 over the square root of 3 is equal to minus pi over 6. Even though there are many other locations where the tangent value comes out to minus 1 over the square root of 3, the only one that's in this interval is minus pi over 6. So folks, this is a really challenging question here. I usually put a question like this on my exam too. And I think it's important to break it up into two parts and write out your two restricted intervals. So you're going to do the first part of part D, this part right here. You're going to use a similar restricted interval that we used for the sine. And for the second part of part D, you're going to use the interval that we restricted for the cosine. So I'm going to let you pause the video, and I've hyperlinked a solution to this particular question, and I want you to first work through it. Use these two previous examples, A and B, as a guide, and try to answer this question. It's tough, but we'll work some more on it in class tomorrow.